A 12.0 gram bullet is fired horizontally into a 100-gram wooden block initially at rest on horizontal surface. After impact, the block slides 7.5 meters before coming to rest. If the coefficient of kinetic friction between block and surface is 0.650, what was the speed of the bullet immediately before impact? We can start off by listing all known values. The mass of the bullet is 0.012 kilogram. The mass of the wood is zero point 0.1 kilogram. The coefficient of friction is 0.650, and the distance the block travels is 7.5 meters. We're solving for the final velocity of the bullet before it impacts the wooden block. The initial velocity of the wooden block after impact is unknown. We start this equation by solving for the initial velocity of the wooden block. We know that the final velocity of the block is going to be 0 meter over second. To solve for initial velocity, we can use the equation v final squared equals to v initial squared plus 2ad. We know v final and distance, and we are solving for v initial, but we do not know the acceleration.
We can start by drawing a force diagram for the block after impact. There are three forces: weight, the normal, and the force of friction acting on the block. The net force acting on the block is equal to the force of friction. We can use the equation coefficient of friction equals the force of friction over the normal force and rewrite it to solve for force of friction. The normal on the block is going to be equal to the mass of the block times gravity. It is important to realize that when the bullet hits the wood, it is going to be embedded in the wood, and thus we must add the two masses together. We know that the coefficient of friction is 0.650, and that the force of friction is going to be 0.112 kilograms times 9.8 meters per second squared times 0.650. We can solve this and find that the force of friction is 0.71344 newtons. To solve for acceleration, we can use the equation force equals mass times acceleration, rewritten to solve for acceleration. We know the force acting on the block is 0.71344 newtons, and the mass of the block is 0.112 kilograms. Therefore, the acceleration on the block is going to be 0.71344 newtons over 0.112 kilograms, which gives us 6.37 meters per second squared. In the case of the problem, we will make this negative 6.37 meters per second squared, because the acceleration is in the opposite direction of the velocity and the direction the block is moving.
We now have all the necessary values for the equation v final squared equals v initial squared plus 280. We can rewrite this equation to solve for the initial velocity of the wood such that v initial equals the square root of v final squared minus 280. By plugging in all values for v final acceleration and distance, we find that the initial velocity of the block after impact is 9.77 meter over second. To find the final velocity of the bullet before impact, we can use momentum, where the momentum of the bullet will equal to the momentum of the wood. Using the equation momentum equals mass times velocity, where we know the mass of the bullet is 0.112 kilogram, and the velocity of the wood is 9.77 meters over second. We can find that the momentum of the wood is 1.09 kgm over second.
We know that the momentum of the wood is going to be equal to the momentum of the bullet, and that the momentum of the bullet is equal to the mass of the bullet times the velocity of the bullet. So we can derive the equation momentum of the wood equals mass of the bullet times the velocity of the bullet, which we can then rewrite to solve for velocity of the bullet before impact, which is going to be equal to the momentum of the wood divided by the mass of the bullet. We know the mass of the bullet is 0.012 kilograms, and the momentum of the wood is 1.09 kilogram meters per second. By plugging in these values, we find that the velocity final of the bullet is 91.23 meters per second, or 91 meters per second for sig figs. We thus solve number 54 by finding the velocity of the bullet prior to impacting the block of wood.